All right, guys, let's talk about polynomials. So this is the intro to the unit, to the module. Got a definition of a polynomial, and perhaps it's better to just jump into the examples and non-examples so we can understand what a polynomial is. So I've got a linear function, all right, and that is a polynomial. I've got a quadratic function, which is a polynomial, a cubic function, and as we continue raising the degree, we find more. We have more polynomials: quartic, fifth degree polynomials, sixth degree polynomials. So I've got a list of some of the vocabulary that we're going to be using in this unit. That's very important. It's not necessary to memorize this on day one, but it's good to have the list because we're going to be using this vocabulary throughout the next couple of weeks. All right. You heard me use the word degree. So let's look at how degree affects sort of the shape of a function. 2x plus 5 is, we know it as a linear function. In other words, it's degree 1. A degree 1 function, you can see basically has opposite end behavior, right? You've come to expect that a linear function, one end is going to go down while the other end is going to go up, right? So to use end behavior notation, as x goes to negative infinity, f of x goes to negative infinity, and as x goes to positive infinity, f of x goes to positive infinity. So that's and even when we negate the slope, we still have one end going to positive infinity and one end going to negative infinity. We'll take a look at what happens when I look at a second degree polynomial. Here's a second degree polynomial, and sure enough, this one has equal end behavior. So both ends actually go to positive infinity. Once again, I can negate the leading coefficient, and there I have a parabola that opens downwards, where basically you have both ends going towards negative infinity. So hopefully you can see a pattern already. And if we look at a third degree polynomial, a cubic polynomial, you're gonna be seeing a lot of these. So really, this intro is kind of the big picture. I like to show you guys what we're going to talk about before we talk about it. All right. So third degree polynomial. Again, sort of like a linear, opposite end behavior. One end goes to negative infinity, one end goes to positive infinity as far as f of x goes. Significantly different from a linear function in that this third degree polynomial has turning points. All right, that's one of your vocabulary words as well. So that's why we're looking at this just as an intro. A neat thing to think about is, all right, so with a linear function, one end goes to negative infinity, one end goes to positive infinity. There are no turning points. All right, at no point does a linear function change direction. Quadratic function, you have the end behavior the same, and you have one turning point. Every parabola has one turning point. All right, so hopefully you're seeing that escalate as well with the degree. All right, when you look at degree 3, here's a cubic polynomial. All right, how many turning points do you see? Well, you see a local maximum at 0.279 and a local minimum at 2.387. So those are two turning points, and you could maybe come to predict how many turning points a fourth degree polynomial would have, and we can come up with one right here. Right there, it looks like one turning point. As I add terms to it, you can see hopefully a little bit better. And if we change some of these coefficients, all right, you can see that there's going to be more turning points. This one, for example, has 3. All right, and that's perhaps too large of a. But again, that continues with the pattern of turning points. Notice that the turning points are always one less than the degree. For example, a parabola you could not draw a parabola with 2 turning points. All right, having 2 turning points would mean that it would have opposite end behavior. So these are just some of the introductory concepts for polynomials. We're going to be looking at their zeros a lot. We're going to be analyzing how can I find these zeros with or without a graphing utility. How can I find the exact zero for negative 0.303? Surely that's an estimate of a zero. Those are some of the things that we're going to be looking at in this unit. One last thing is that the degree of a polynomial cannot be a negative. You cannot have a negative exponent. That would be a rational function, which we're going to study in another unit. That's an intro to polynomial functions.